A BCA table can only be used with units of moles because we can't use the mass in grams because elements on the periodic table, as we've learned before, all are different sizes. So we use the molar mass to get out the effect of the different sizes. So we just want to compare number of particles, specifically atoms, from the beginning of the reaction to the end of the reaction. Therefore, before we use the BCA table to relate amounts of reactants and products, we have to convert any measurements that are originally in grams into moles. And any measurements that are in moles after we use the BCA table can be converted to grams if we need our final answer to be in grams. Therefore, we're going to have to review how to convert back and forth between moles and grams. Therefore, I'm going to do a quick review with you on how to go back and forth between grams and moles. So we have learned that the molar mass is the mass for 1 mole of a particular substance. We have also learned that you can find the molar mass by adding up the molar masses of all the individual elements on the periodic table that are combined in that compound, and everyone should remember how to do that. So let's look at 2 quick examples, one going from grams to moles, the other going from moles to grams. We're going to set up a proportion just like we always have. So the first one says how many moles are in 5.21 grams of C2H6. So first I'm going to figure out the molar mass of C2H6. So I took the molar mass of carbon times 2, because there are 2 carbons in every 1 molecule of this C2H6, and I took the molar mass of hydrogen times 6, because there are 6 hydrogen atoms in each molecule of C2H6. So I found that the molar mass was 30.0694 grams in 1 mole, and that's going to be my template for setting up my proportion. So the 1 mole always goes with the molar mass, because the molar mass is the mass for 1 mole. So you always, in your proportion here, want the 1 mole paired up with the molar mass that you calculated from the periodic table. On the other side of our setup is the numbers that we get from our problem. So we know we don't have 30.0694 grams of C2H6. We have 52.1 grams, and we don't know how many moles we have. But it looks like it's going to be a little more than 1 mole because we have a little more than 30 grams. So I'm going to cross multiply here. 30.0694 x equals 52.1. And I'm going to divide both sides by 30.0694. So x, my number of moles, is 1.73 moles. And I've given it with 3 significant figures because my original number has 3 significant figures. So as a for every statement, I could say there are 1.73 moles in 52.1 grams of C2H6. Next, we'll look at a problem that goes in the opposite direction. We are given moles, and we want to convert to mass. Still, the factor that relates moles and mass is molar mass, the mass in 1 mole. So I'm going to look up the molar mass of carbon and oxygen and calculate molar mass. So the first thing I did was found the molar mass of carbon dioxide. Took the molar mass of carbon plus the molar mass of oxygen times 2 because there are 2 oxygen in every molecule of carbon dioxide, and I got that the molar mass was 44 grams in every 1 mole. And again, I'm going to use that to set up my proportion. So again, the 1 mole always goes with the number from the periodic table. The molar mass is the mass of 1 mole. And we don't have just 1 mole, we have 3.75 moles, and with all proportions I match up my units, so I'm going to put moles on the bottom because I've got moles on the bottom over here. So I do not know this time the grams. Then I'm going to cross multiply. 44.099 or 009 times 3.75 is equal to x. So there are 165, again with 3 sig figs, grams of CO2 in 3.75 moles of CO2. And this should make sense because we had 3.75 times as much carbon dioxide moles, so my mass should be 3.75 times bigger than the mass of just 1 mole. So you should feel like you've had a good refresher on how to convert back and forth between moles and mass, and we'll be using it a lot more in this chapter.